So hello my colleagues, and I do hope everyone is well. What I'd like to do is talk to you about net present value, and because there's been some questions about what net present value is, okay? So in simple terms, what net present value is if I invest X dollars, whatever that is today, in a project, is it worth doing it or did I lose money? Okay? Or did I lose money? And I'm going to do a simple example, and I think this will help you really get a good feel for what net present value is. Okay? Now the rule of thumb is and we'll go through the math later. If I take the present value of all my cash flows, okay, and bring it to today so I can compare it to what I paid and I subtract them, which I'm going to do here, okay, okay, you'll see that it was either worth doing or not worth doing, okay? So we're going to find that if this is negative, it's not worth doing the project. If this and in Excel, negative means it's in parentheses, okay, and it's red, okay. If it's worth doing, the parentheses will go away, and it's worth doing. Now let's do a simple example, and I'm sure you're all familiar with LED light bulbs. Okay, so you can go to Home Depot and buy an LED light bulb, and let's assume the LED light bulb is going to save you're going to pay $20 for the LED light bulb. Okay. Now the person in the store said, "That's a smart move. You're going to save money on that light on your electric bill by using that LED light bulb." However, instead of buying that light bulb, you could have taken this money right here, this 20, and invested it somewhere, maybe and got 7%. So let's assume your cost of capital, we're going to assume that, okay, is 7%. So the question is, according to the salesman, really was it worth doing? So you bring the light bulb home after you pay 20, and you're finding out you're saving $1 a year on your electric bill, okay? You're saving $1 a year on your electric bill. And the question is it worth doing if you're going to save $1 a year for the next 20 years? Okay? So let's go through some of the math, and we'll figure that out. So if we were to put this on a timeline, okay, this would be our initial investment, and you notice it's $20, right? Because the money came out of your pocket, and on a timeline, you're saving $1 a year. So here's your $1 a year, and your cost of capital is 7% annually, okay? So the question is, was it worth doing? So first thing we got to do is we got to get the present value of these cash flows. So you see this green number here? I'm going to click on that. Now you'll notice that's the present value of the cash flows. Here's the interest rate. Let me open that. Here's the interest rate, and I'm using cell-based mathematics. E1 was the interest rate. Notice how it put 0.07. Number of periods was 20. I just typed that in myself for the heck of it. I could have put a 20 in a cell. And the payment, okay, is minus C1 here. Okay, so I took one payment 20 times. All right. So I say okay, just to get the present value. And you'll notice here that the present value comes out to $10.59. Okay. So if I take that present value, because I brought it back to the beginning, and I subtract off my initial value, or in this case, add my initial value because it's negative already, you'll notice my net present value is $9.41 negative. So it wasn't worth doing this project. Okay? So over 20 years, you're still losing money on spending $20 on this light bulb. So the question is, how much would you have to save every year for this light bulb to be worth doing? Okay? So let's go in here, and let's say you save $2 a year. All right? And I'm going to pull this down just so you see, right? We're saving $2 a year for 20 years. Now, look at this. It's a wonderful life. If you save $2 a year, the present value is $21.19, and if I subtract off the 20, it's worth doing the project because I'm going to save $1.19 over 20 years. Now, you may not like that. Okay, so it's only $1.19, but it's still worth doing. Okay, it's still worth doing. All right. Now let's say let's go crazy. Let's go crazy. Let's say you save $10 a year. Let's say you save $10 a year because it's a wonderful life, right? And I'll just drag it down again. Now, look here. If you save $10 a year, your present value is $105.94, and I'll click on that and show you that. Look, right? There's the C1, right? And if I subtract that, here's the present value, right, in green, from the $20 that my initial investment, my net present value is $85.94. So over 20 years, you're saving almost $86, and you can see the simple math for net present value. All it is G3, which is in green here, right, which is the present value of my cash flows, and I did plus $20 because I made that negative, all right? So you can see it's worth doing. All right. Now, so what I'm showing here is if I take these cash flows, and you can see what I'm doing is I'm getting the future value each year, and you could, if you click on this and basically I'm multiplying this number for the next year by 1.07, and then I put that there, and again multiply it by 1.07 and put it there and multiply by 1.07. So I'm getting basically how much you're going to basically have in the future, okay? If you had 105.94 today and kept getting 7%. And it would work out that in the future, if you do each year individually, you would have 409.95. Everyone see that? Now, I shouldn't put this in red. This is not negative. So really, this shouldn't be in red. I don't want everyone to think this. I just highlighted it. So this is positive. So this grows. Now, to show that that's true, I use the future value function right here. Look, 7%, 20 years. And here's G3, right there. And look how it grows. Exactly the same. Okay, you see this and you see this. So let me open this up. 7%, 20 years minus G3. Because again, that's out of your pocket, right? In the future, you'll have 409.95, which is the same thing I did, but I did it longhand, 1 year at a time. All right, so the question is, at what point will I just break even? At what point will I just break even? And just have, $0. So let me fool around a little bit and make that $1.89. So I made that $1.89, and I knew what it was going to be already. So you can see here, if you get back $1.89 a year, you're just going to break even. You're basically 2 cents ahead over 20 years. Okay, here's your present value. I subtract off my initial investment, and I'm 2 cents ahead. And you can see the future value worked out the same way. Okay? So I hope everyone is kind of clear on that with this simple light bulb problem. Now, a lot of people also do it with electric vehicles, right? And what do they say? If I spend extra money on an electric vehicle because it's going to cost me more and then have to buy a maintenance agreement, is it worth doing if I'm going to save X dollars a year on gas? So you have to do a net present value evaluation of an electric car to determine if it's worth buying, if you're going to save enough on gas to spend the extra money on an electric vehicle. All right? And a lot of times it isn't worth doing, okay? Because you don't have the car that long. I hope everyone is clear on what I'm saying. This was a simple light bulb example that you bought in Home Depot. And basically the question was it worth spending 20 bucks on that light bulb? Okay? And most of the time it kind of isn't, because if the light bulb dies before 20 years, you got to buy another one, and it's really not worth doing. All right, if anybody has any questions on that, get back to me, okay? I hope I was clear.